My name is Dave Horrigan, and I build large, strange, and wonderful things. Things like, things like privately owned submarines. Chief engineer on that thing for 3 years and built it. Things like rebreathers, things that allow you to breathe underwater for 14 hours at a time, and it's been tested by a human at 450 feet. The invention I'll be showing you today is maybe the largest, strangest, and most wonderful yet. What it is a propeller, specifically a high-efficiency ship propeller. It's designed to address the problem of polluting ships. Maritime shipping produces 14% of all transportation carbon dioxide emissions. That's 1 billion tons of carbon dioxide every year that go into the atmosphere because of commercial shipping. That's more than the annual emissions of Germany, South Korea, Canada, and the United Kingdom. And this sector continues to grow. We expect to dramatically reduce that number. The SolidWater propeller that I'll be showing you delivers an improved flow. How improved? Our very first prototype delivered 5 times the flow over a fully engineered propeller. And we made 2 modifications to that and upped it to 7 times. The flow was high speed and laminar. But, like this guy here, some like the high speed bit, but some are more impressed by the incredible fuel savings. And the prop features multi-directional thrust, eliminating tugboats in some cases. And the SolidWater propeller is reliable, a critical necessity at sea. The SolidWater prop acts as a highly efficient brakes for stopping and reversing without a transmission. And because the SolidWater prop varies its pitch throughout its cycle, it can be very high speed as well as being maneuverable. Here's our competition. The red one on this side is made by Rolls-Royce. It's called an azimuthing pulling propeller. Because it pulls instead of pushes, it's 40% more efficient than traditional propellers. It's very hot and popular right now. It's being used on a lot of military vessels, cruise ships, as well as tankers. But that's the old technology. The SolidWater, compared to the Azipod particularly, our SolidWater moves much more water per RPM than the Rolls-Royce. That may not be useful information to most of you, the moving large amounts of water, but let's hide this one here. The amount of horsepower, the purple one in this case is the Rolls-Royce. This one is our prop on the same vessel to achieve 16 knots in speed. That's the difference in the amount of horsepower required. This is a huge deal. What makes it unique, and somewhere around here I have a demonstration. Here are a couple of blades that are actual blades off one of the prototypes. And it runs a motion that goes like this, around and like this, out like this. This push forward, this pushes forward. And of course, if you reverse them, this pushes back, this pushes back, this pushes back. And there's no drag in the neutral positions. Note the blade is a different shape too. And I'll get into that later. Here's the linkage, very simple. If you stop this, if this is solid, then that goes that way. If you fix that so it can't move, then it becomes a pump or a fan, and the fluid moves this way. Now, the first thing that makes it special is a 70% improvement over traditional props in fuel. Instead of installing a 17,000 horsepower engine, consider a 5,000 horsepower to deliver the same thrust. Plus, there's no rudder or shafting to drag, install, or to maintain. Plus, it has benefits such as non-fouling, swimmer safe, easy to repair at sea, retractable, and it doesn't travel at one fixed speed. So whatever you need to do, it will do for you. Did somebody have a question there? Okay. Tug like this in San Francisco has 2 engines delivering 100 tons of thrust, runs 24 hours a day. We did the math and concluded we could save them $4 million a year in fuel per engine per 12-hour period. So you get an idea, it's pretty easy to sell to someone who owns a boat like that. The market, we plan on 3 models, a 1-ton thrust model, a 10-ton thrust model, and a 100-ton thrust model. The prices will range from $220,000 to $5,200,000, plus the engines and the engineering support. Fish had a good idea, but it's not 2 heads. 2 tails is what solves the problem. And we have 2 in each of ours to balance the whole thing out. So we have improved in the blade design, and this little gadget here shows a little demonstration of what it looks like. This is actually 10 C-sized flashlight batteries. And that is moving a wall of water that is this big. And in this one, we actually broke it a little bit later on in the movie, but I'm running out of time. So if you're interested in more information, I will be presenting a 1-hour discussion to the Marine Technology Society and the Society of Naval Architects and Marine Engineers on the 28th of this month. Go to the website mts.sandiego.org, mts-sandiego.org, and I'd be happy to answer any questions after the contest. And please vote for me. Thank you very much.